So we'll try to make a transition here into the broader Germline working group efforts, which I think the past few minutes of conversation lead nicely into. So a brief, I suppose, reminder of what our mission is, which is something that we established several years ago now, and I think still is a reasonable mission that we kind of continue to apply to our work. So the goal of the Germline Working Group is really to promote the comprehensive and accurate identification, description, classification, annotation, curation, and consistent use of germline IG and TR genes and alleles across species, strains, and populations. So there's a lot to unpack there, none of which we won't really do in any detail here, but this is something that we all of us in the working group think deeply about, and we try to consider all of these aspects when we approach the problems that we're trying to tackle. Just briefly, this is the list of people who wished to be named as part of the working group. I think our mailing list is quite a bit more extensive than this, but these are the folks who have been attending regularly, and Andrew and myself are co-chairs, at least for the moment. So if we were to recap goals set at AIRR4 or the last community meeting in Genoa, a good bulk of those were IARC related goals, which Andrew pretty much just covered all very nicely. And then we had a set of non-human goals, which I'll sort of speak to here for a few more minutes before passing back over to Andrew. So there were 3 main species that we sort of initially set our sights on. So the first one I'll show you a slide on briefly is for salmonids, so salmon and trout. And then we have also been really focused as a working group on both mouse and rhesus, which I'll talk about in more detail here momentarily. So for salmon and trout, this is work being led by Pierre Boudneau and Susanna Magadan. And they have published a paper in the last year, and I believe have a new paper that is recently been accepted or due to come out soon. And they have done the tedious work of doing the initial genomic descriptions of both Atlantic salmon and rainbow trout, discovering lots of new genes, and they have worked closely with Marie-Paul Lefranc to establish a position in subgroup-centric based nomenclature, and they are now, or have now recently extended into a second strain of rainbow trout, and they are coming across many of the things that those of us in the human space, as well as mouse and rhesus, have been noticing for several years as well, and that the second you go into another animal, things get more complicated and do so very quickly. And so they've done work now on a second strain and are identifying new genes and loci. And one important thing just to highlight here, because it'll be a theme that we sort of touch on again in the next couple minutes, is that in this sort of second iteration, I think largely because of the passage of time, the genome assemblies they're working with now, they're stating are of better quality. And this is something that is a sort of general issue or topic that the working group is really starting to think a lot about now, because the field in which we're in is changing rapidly, and the data sets we have available to us are evolving. And so as you come into these new, better assemblies, you find new signatures and trends that maybe you didn't see before. And nonetheless, what they've seen is with these new strains is, more genes and alleles. And so they're sort of changing the way in which they're approaching the naming and now using consecutive numbering as well with all the new genes. And there's an example of one that they have put down here. And they are also actively annotating TR genes as well, and additional assemblies. So really generating some great data sets and really useful resources for the salmoniid communities. Despite lots of intense effort, I would say that progress in mouse and rhesus has not quite been as productive in terms of amounting to tangibles in the way that the salmonid efforts have. But in our last meeting, it was recognized that these were species with databases that needed a lot of work, for which that we understood there were a lot of data sets available, and in these data sets, there was a level of diversity being described that was very poorly represented by the existing databases. And so as a working group, we've set out in the last 12 months to really try to address these topics. And it's proven to be quite challenging for various reasons, which we can discuss later on. To sort of sum this up in one slide, which is relatively unfair, but I'll try anyway. The gist of it is if we look at mouse, as we just talked about, we can see that if we move beyond C57 Black 6, that pretty much many of the other strains that have been investigated to date have evidence for extensive diversity. And in many cases, these animals likely carry haplotypes that don't resemble or are highly divergent from what you see in the C57 Black 6 assembly. At the moment, if we take into account inferences from repertoire AIRR-seq data, there's suggestion that there's hundreds of alleles that are out there among various mouse strains that aren't currently represented in any database. And so, this is obviously both an issue for being able to use these data effectively, but also we currently don't have any system by which to apply a naming strategy to these sequences that's at least been formalized. And in a similar yet different way, we see very, I would say, comparable patterns in rhesus, where existing germline databases are far and away incomplete and do a very poor job of representing diversity that's known to exist in the species. It's clear now from lots of work, particularly that coming out of the Hedeston lab, that rhesus is incredibly diverse, very, very polymorphic, and two animals tend to carry different sets of alleles on average. We know, as there have been efforts to sequence genomes of rhesus in recent years, that the locus structure is also incredibly complex. And this has raised issues as well for us, similar to those in mouse, in which we see examples that a single reference assembly is actually doing a very poor job of representing the diversity that we are likely to encounter in the population. And so this, of course, has raised issues for us about how do we think about doing a better job of applying nomenclature strategies and really forcing us to think outside the box and to think forward into the future a little bit about how do we build better nomenclature systems that are going to be able to account for these types of signatures or data sets that we're likely to encounter moving forward. So there has been some progress. These groups have been relatively active throughout the year. There was a commentary paper, a position paper that was published at the end of 2019, early 2020, by some of us in the mouse subgroup to sort of outlines many of these problems and try to promote a solution or a set of solutions for some of these issues. However, we still haven't really gained full traction on that idea formally. The Macaque group has really been trying to review data. There's been a paper published recently from AIRR-seq data, again from the Hedeston lab, and there are also a couple papers from other groups that are really sort of putting the AIRR-seq data out there in the ether, but we have yet to come up with a way to sort of really rein those in and come up with a naming system that could be partnered well with the complex genomic data that we're seeing. And through a lot of this discussion both with Rhesus and Macaque, what we've really kind of come around to the realization of is, in contrast to what we've been doing in human, these conversations have really highlighted a deficit in the processes that we all use, and processes I think that are have impact on the AIRR-C or on the AIR community in terms of thinking about ways in which we get new data and use that data to discover and curate and name genes. Those processes appear to be somewhat broken or at best disjointed at the moment. And so this has really sort of turned our focus to what Andrew's going to talk about in the next few slides, which is thinking more about, okay, we have an opportunity here to maybe shift our thinking a little bit and be a bit, use history to our advantage, but think into the future so that we can maybe come up with some better strategies for how we move forward and derive the most benefit for the AIR community and its research users. So with that, I'm going to pass the baton to Andrew, hopefully seamlessly, and I will help him advance his slides.
Yeah, so as Corey says, the differences between the mouse strains and individual macaques have really preoccupied us. And this has led to debates within the working group about the implications of this for our nomenclature. And this led to agreement that these 4 things are what we want from a nomenclature, and I'm going to consider them in turn. So the first point, if we can move on, Corey. Certainty. We want to be certain about what sequence is described by a name, and name changes make this difficult. This is particularly true if names are reused. That is, if a name is first applied to one sequence and later to another. Next slide. So several months ago, we discovered that there's been a wholesale renaming of macaque IGHV genes. This is a screenshot of the top part of a very, very long table of changes. And you can see that there have been drastic changes to names. Next slide. So here we've added another screenshot from lower down the table, which shows that not only have names changed, but they've been reused. So if you look at 3.3, for example, circled down at the bottom right, there was a sequence called V3301, and it's now called V318102, and I don't know why. There is another sequence that is now called V3301 that you see at the top left, and it was previously called 32401. And no explanation is offered for this table of changes. Next slide. So what we require is clarity apart from certainty. And by this, I mean that we need to understand why things have happened. I struggle to think of a reason, but if there is a good reason to change a name, this needs to be documented. And at present, we don't have such clarity. Next slide, please. Neither do we have speed. And, you know, as someone who's been concerned with errors in the reference directories for a long time, you know, I believe in care. And so decisions have to be, they have to take some time, but that isn't what is behind the problem that I'm talking about here. Next slide. There are, as the slide says, literally hundreds of mouse and macaque sequences that remain unnamed that we are absolutely confident are real, and they're not presently named because they don't meet the current requirements for naming. These sequences, in many cases, have been known for 5 years. But it's the current naming requirements that are the problem. Next slide, please. So what are these requirements for naming? Well, the sequence has to be a genomic sequence. It has to be a complete coding region, as well as the complete leader sequence and the downstream recombination signal sequence. And it must be a MAPS sequence mapped to an agreed annotated reference sequence. Next slide. But unmapped sequences that only include the coding region can be of high quality, and we need to know about these sequences, which is not to say that non-coding regions are unimportant, and if, in fact, they're of increasing interest to the working group, and we'll be paying much more attention to these regions in the coming years. Now, I haven't mentioned future proofing. There isn't a slide, but it can be explained in the context of the Infertile Allele Review Committee, and in fact, what I said in answer to a question before. So the IARC provides the only presently accepted route to circumvent the naming rules because our inferences are of unmapped sequences that only include the coding regions. So in this respect, the development of the IARC allows the human nomenclature to be future-proof or relatively future-proof. But as I said in my IARC presentation, without changes, the IARC process can't really be easily applied to the mouse. And so the mouse nomenclature is not future-proof. In fact, it's not even coping with what we've got at present. Next slide, please. So where do we go now? Let's move straight on. So these issues can only be resolved with the agreement of the naming authorities. And fortunately now there are a number of members of the RUIS subcommittee that's recognised as having authority over immunoglobulin and TCR names who are members of the working group. And Kathy Skeepers is now the co-chair of that committee. Next slide. So as we look for goals for the next year or so, at the top of our list is the need for the ratification by the naming authorities of the kinds of principles that I've described. That is the need for certainty, clarity, speed, and future-proofing in the naming of immunoglobulin and TCR genes. Within the working group, we hope to begin discussion on non-coding regions, and we hope to finally make progress with the mouse and macaque, and we hope to see more attention given to TCR inferences, and this will be done by a subgroup led by Jamie Heather. It may lead to the establishment of a human TCR IARC, we'll see. Next slide. We'll also be trying to understand how we can ensure that new sequencing technologies will help us rather than hinder us, and we'll continue to advocate for better database versioning and access. Next slide. So finally, Corey and I are calling for nominations for leadership of the working group, and we're asking members of the working group, if they're interested, to nominate or self-nominate. Send your nominations through to Pam, and we will then take these nominations to the first meeting of the working group in the new year. Final slide. If you're not yet a member of the working group and you have an interest in germline genes, please consider joining us. We're keen to have new members. Simply send an email to me or Corey and we'll sign you up. Thank you.
Fantastic. Thank you, Andrew and Corey, for a very clear and outstanding presentation of both the IARC and the Germline Database Working Group. Since we're running a bit over time, are there any, and I want to kind of, I think we're going to buy back a little bit of this time in the Hot Topics session. So I wanted to just preserve Andrew's sleep cycle. If anyone has any burning questions right now for Andrew or Corey, please raise them, and then we will carry on with the program. Any questions? So we have one, it looks like, from Maggie. Are the issues with the Rhesus AIRR-seq database entries similar for TCR genes?
Yes.
In a word.
Yes. Yeah, that can save us some time. Happy to elaborate that later if you need to.
Okay, great. Any other questions from the group? Oh, looks like we have one other. Nope, that's it, I think, right? Yeah. All right, so with that, thank you again, Corey and Andrew. We will certainly continue the conversation. You've raised a lot of really important points. I especially appreciate your goal of promoting clarity, or sorry, certainty, clarity, future-proof, and speed. I think I have that in the right order, for nomenclatures of immune repertoire genes, and the work that both the Germline database and IARC are doing is incredibly important. So thank you again for that.